This is day 5 of Advent of Cyber 2025, and this challenge is called IDOR, Santa's Little IDOR. The elves of Wareville are on high alert since McSkitty went missing. Recently, the support team has been receiving many calls from parents who can't activate vouchers on the Try Present Me website. They also mentioned they are receiving many targeted phishing emails containing information that is not public. The support team is wary and has enlisted the help of the TBFC staff. And looking into this peculiar case, they discovered a suspiciously named account named Sir Carrotbane, which has many vouchers assigned to it. Now, they have deleted the account and retrieved the vouchers. But something is going on. Can you help the TBFC staff investigate the Try Present Me website and fix the vulnerability? The learning objectives for this challenge are to understand the concept of authentication and authorization, learn how to spot potential opportunities for insecure direct object references, and exploit IDOR to perform horizontal privilege escalation, and learn how to turn IDOR into SDOR, secure direct object reference. So for this challenge, we need both the attack box and VM. So we will turn both of these on and check, and we'll carry on with IDOR on the shell. It's dangerously obvious, really. Have you ever seen a link that looks like this? Normal URL, which then has parameters package ID 1001. When you saw the link like this, have you ever wondered what would happen if you simply change the package ID to 11 or 12? In its simplest form, this can be a potential case for IDOR. Insecure direct object reference is a type of access control vulnerability. Web applications often use references to determine what data to return when you make a request. However, if the web server doesn't perform checks to ensure you are allowed to view that data before sending it, can lead to serious sensitive information disclosure. A good question to ask then is, why does this happen so often? We need to understand references and web development a bit more to answer this. Let's take a look at what a table storing these package numbers from our link example could look like. So you have the package IDs here, and those are used to identify the person, address, and their delivery status. If the user wants to know the status of the package, make a roll request. The simplest method is to allow the user to supply the package ID. We then recover data from the database using simplest SQL query of select person address status from packages where package ID equals value. However, since package ID is a sequential number, it becomes pretty obvious to guess the package IDs of other customers. And since the web application isn't verifying that the person making the request is the same person as the one who owns the package, an IDOR vulnerability appears, allowing attackers to recover the details for packages belonging to other users. Even worse is when a feature like this doesn't require users to authenticate. Then there would be no way to even tell who is making the request. To dive a bit deeper, we need to understand authentication, authorization, and privilege escalation. So to understand the root cause of IDOR, it is important to understand the basic principles of authentication and authorization. Authentication is the process by which you verify who you are. So for example, supplying your username and password. Authorization is the process by which the web applications verify your permissions. So for example, are you allowed to visit the admin page of a web application? Or are you allowed to make a payment using a specific account? You may think that authentication only happens once when you supply your username and password, but that is actually not the case. After providing your credentials, you receive a cookie or a token called session information. Every subsequent request you make to the application includes the session information, which is verified by the web application. This initial verification process is still authentication and happens for each request. This is why websites will often redirect you back to the login page. It means your session information has expired, and thus you need to re-authenticate with your credentials to receive new session information. Authorization cannot happen before authentication. If the application doesn't know who you are, it cannot verify what permissions your user has. This is very important to remember. If your IDOR doesn't require you to authenticate, login, or provide session information, such as in our package tracking example, we'll have to fix authentication first before we can fix the authorization issue of making sure that the users can only get information about packages they own. The last bit of theory to cover is privilege escalation types. Vertical privilege escalation refers to privilege escalation where you gain access to more features. For example, you may be a normal user on the application, but can perform actions that should be restricted for an administrator. Horizontal privilege escalation refers to a privilege escalation where you use a feature you are authorized to use, but gain access to data that you're not allowed to access. So for example, you should only be able to see your accounts, not someone else's accounts. IDOR is usually a form of horizontal privilege escalation. You are allowed to make use of the track package functionality, but you should be restricted to only performing that tracking action for packages you own. So now that we understand the theory, let's look at how to exploit IDOR properly. So we'll be in our attack box, bringing up Firefox, and we'll be going to the website that is running on the virtual machine. So copy the URL that's there, put it into the keyboard, the clipboard right here, and then enter it into the URL in your attack box. And with this loaded, we will enter the credentials. So like so, we will then log in, and as we are authenticated, we can see dashboard here. So it wants us to use the developer tools, which you can bring up by going to the burger menu here, going more tools and web developer tools. So if we go to the network tab and we refresh the page, we can see all requests which are being made. And as highlighted here, we're seeing view_account info, and it's providing the ID for the user. If we dig deeper into this one, you can see the URL parameter user ID is equal to 10 right there. And in the response, we can see the data that's being returned for the user that we signed into. So this tells us that the application is using our user ID as the reference for getting details. Let's see what happens when we change this. In the developer tools, navigate to the storage tab, expand the local storage dropdown on the left side and click the URL inside. Inside of here, we go to storage and local storage for this website. You can see our auth user here. And if we change this, so user ID is now 11. And if we refresh the page, is it saying? Although when I refresh the page, it made me sign out. So let's try login again. Okay, still has user ID 10 for me. So let's go storage. We'll change it back to 11. Okay, there we go. Refresh the page again. And now we're seeing the test@test.com user. So it wants us to change back to our actual user ID of 10. Refresh it here again, back to normal. So some IDOR may not be as simple as just a number. In certain cases, encoding may have been used. In the loaded profile, click the eye icon next to the first child as shown on the image below. So if we go to my children, click on the eye, and we see child ID 2. But if we go to the network tab, then we can see this request was made here, mg ==. But if we go to if we look at the headers, we can see it's /API/child and then base 64 mg ==. So that appears to be using the child ID 2 and then base 64ing that number, maybe. So simply put, mg == is just the base 64 encoded version of the number 2. Okay, yeah, that's what that's doing. So encoding isn't the only thing that can be used to hide potential IDOR vulnerabilities. Sometimes the values may look like a hash, such as MD5 or SHA-1. If you want to see what that would look like, take a look at the request that happens when you click the edit icon next to a child. If you go to the edit icon, you can see there's an MD5 here. So assets MD5 dash, oh no, it's this one here. So MD5, and then it's got this one. Probably safe to assume that it's MD5 hashing the number 2 for the ID. So while the string may look random, upon further investigation, you can see that it is a type of hash. If you understand what value was used to generate the hash, we can perform an IDOR attack by simply replicating the hashing function. Using something like hash identifier, can you quickly understand what hashing algorithm is being used, and can often tell you what data was hashed. To determine this, sometimes you have to dig quite deep for IDOR. Sometimes IDOR is not as clear. Sometimes the IDOR stems from the actual algorithm being used. In this case, let's take a look at our vouchers. While the values may look random, we need to investigate what algorithm was used to generate them. Their formats look like a UUID, so let's use a website such as UUID Decoder to try to understand what UUID format was used. We go back to, so from there and go to the voucher. So if we select my children voucher, have these values, we'll just look at what they're doing. So they copy that first one to here. Appears to be version 1 UUID. And we can see the contents of the UUID are basically just a date and time. We've got time, look, the node. While these look completely random, you can see that the UUID version 1 was used. The issue with UUID 1 is that if we know the exact date when the code was generated, we can recover the UUID. So for example, suppose we knew the elves always generated vouchers between 2000 and 2100. In that case, we can create UUIDs for that entire period. 3600 UUIDs, since we have 60 minutes and 60 seconds in a minute, which you could use in a brute force attack to aim to recover a valid voucher and get more gifts. So now that we learned about what IDOR is, let's discuss how to fix it. The best way to stop IDOR is to make sure the server checks who's asking for the data every time. It's not enough to hide or change the ID number. The system must confirm that the logged in user is authorized to see or change the information. Don't rely on tricks like base64 or hashing the IDs. Those can still be guessed or decoded. Instead, keep all the real permissions checks on the server. Whenever a request comes in, check, does this user own or have permission to view this item? Use random or hard to guess IDs for public links, but remember that random IDs alone don't make your app safe. Always test your app by trying to open another user's data and making sure it's blocked. Finally, record and monitor failed access attempts. They can be early signs of someone trying to exploit an IDOR. Okay, so now on to the questions. What does IDOR stand for? We go back up. Insecure Direct Object Reference. Okay, so then check. Okay, what type of privilege escalation are most IDOR cases? That was horizontal. Exploiting the IDOR found in the view accounts parameter. What is the user ID of the parent that has 10 children? So I assume it wants us to play around with the local storage user ID. So let's change some IDs and try find the one which has 10 children. So the test one has none, 12 has none, 13 has none, number 14 has 2. This one appears to have 10. So this one was ID 15. So let's enter that in. That was correct. Okay, so it's got a couple of bonus tasks. If you want to dive even deeper, use either the base64 or MD5 child endpoint and try to find the ID number of the child born on 2019-04-17. Make the iteration faster, consider using something like burp intruders. Well, we aren't going to do any of those bonus ones, so we will just go through and check on all of those. And that is day 5 of Advent of Cyber 2025 complete. If you like this video, make sure to like and subscribe.